So good morning all. Welcome to Sakala Vidya YouTube channel. Okay. Good morning everybody. So in the last class we have completed 44 problems. Today we shall continue the chapter. Okay. Okay. Right. Question number 1 minute. I will come. 1 minute. Forty-five. Question number 45. Integral 0 to pi sine of x by 2 raised to 8 dx equals to. This is the question. Okay. 35 pi upon 128. Second option 5 pi upon 128. Third one 25 pi upon 128. Fourth option 3 pi upon 128. This is the question. Sriya, actually I kept that your suggestion. Sure, I will start. Right. Integral 0 to pi sine of x by 2 all to the power of 8 dx. So first we need to change x by 2 as x. So that means now the solution, let us say this t equals to x by 2. Now x equals to 2t. Dx by dt equals to 2. Now dx is replaced by 2 dt. So now we need to change the limits also with respect to the substitution. Now here upper limit is x is pi. Now the t becomes, when x is equal to pi, t becomes pi by 2. Upper limit changed to pi by 2. Lower limit x is equal to 0. Now t becomes 0 by 2, 0. Now this integral becomes I equals to integral lower limit is 0, upper limit is pi by 2. This is sin t raised to 8. Now dx is equal to 2 times dt. Take 2 common. If you take 2 common, integral 0 to pi by 2. This is sin t to the power of 8 dt. T is the dummy variable. It is just like integral 0 to pi by 2 sin x to the power of 8 dx itself only. Understood now? So that means now whenever if you want to solve integral 0 to pi by 2 sine x to the power of 8 dx, so equal to, so already 2 is there, 2 multiplied right down. Whenever power is 8, either it is sine power or cos power, you remember one shortcut. What the shortcut means? Count the numbers from whenever even power is there, start the counting from 1. 1, 2, 3, 4, 5, 6, 7, 8. Stop. Whenever even power is there, multiply with pi by 2. That's all answer. You get the answer. Once again I will repeat. See here now, whenever actually sin x to the power of n or cos x to the power of n dx is there, you remember very beautiful shortcut here actually. So this shortcut actually somewhere you might have not actually experienced about this shortcut. So whenever even number is there, start the counting from 1 to 8. You need to do it. 1, 2, 3, 4, 5, 6, 7, 8. Then multiply with pi by 2. So now you check it now. This 2 gets cancelled. This equal to now 3 1 ja, 3 2 ja. That means actually 35 pi upon 4 2 ja 8, 4 2 ja 8, 8 is ja 64, 64 into 2, 128. So that means first option is the right option. First option is the right option. Right. Forty-sixth problem. 46th problem. Integral minus 2 pi to 2 pi cos x to the power of 6 dx. First option 0. Second option is 5 pi by 4. Third option is 5 pi by 8. Fourth option is 3 pi by 8. 3 pi by 8. Okay, now integral minus 2 pi by 2 to 2 pi cos x to the power of 6 dx. So now the solution, say I equals to integral minus 2 pi to 2 pi cos x to the power of 6 dx. See, this is seems to be minus a to a, means even function or odd function we need to check. Since power is even number, definitely it's a even function. So that means cos x to the power of 6 is even function. So when it is even, you can write this is 2 times integral 0 to 2 pi cos x to the power of 6 dx, you can write it. And one more case we have, whenever integral 0 to 2 pi cos x to the power of n dx equal to 4 times integral 0 to pi by 2 cos x to the power of n dx if n is even. If n is even. Understood now? So that's why now directly we can write this equals to, now already 2 is there, 2 multiplied by 4 times 0 to pi by 2 cos x to the power of 6 dx. Now you can apply the formula for this one. Already 8 is there, 8 multiplied by Here now cos x to the power of 6 dx. 6 means even number. Counting start from 1. 1, 2, multiplied by 3 up, 4 down, 5, 6. Counted up to 6. 1, 2, 3, 4, 5, 6. Multiplied by even number is there pi by 2. So 4 2 ja 8, 4 into 2 8, 8 cancel. Actually we have 3 1 ja, 3 2 ja. We have 5 pi upon 4. So second option is the right option. Second option is the right option. Okay. Forty-seven. Question number 47. Yes, option 2. Correct. Suma, Vallabh, Chand Pasha, Narla Venkateshwari, Abhiprakash, Suma, 47. Okay. Balu, Kartikeya, Kirti, Swati, Surya Teja. Right. 47. Integral 0 to pi by 2. Integral 0 to pi by 2. Tan x to the power of 5 dx equals to, first option 1 by 2 log 2 plus 1 by 4. Second option 1 by 2 log 2 minus 1 by 4. Third option 1 by 4 log 2 minus 1 by 4. Fourth option 1 by 2 times log 4. Okay. So now we need to find out integral 0 to pi by 2 tan x to the power of 5. Sorry, this is pi by 4. I have given wrong. This is pi by 4. Whenever tan is there, cot is there, secant x is there, cosecant x is there, 0 to pi by 4, we have the formula. For sin cos 0 to pi by 2. Okay, now, so you need to remember one short formula, reduction formula. Integral 0 to pi by 4 in tan x to the power of n dx equals to 1 by n minus 1, alternative sign change, minus 1 by, here subtract 2, that means n minus 3, okay, n minus 3 plus subtract 2, n minus 5, because up to 5 there, we need not make use of this one. 5 minus 5 minus 0 becomes 0. That means minus dash dash plus I naught or I1. Accordingly, n is even or n is odd. So that means actually here see, now I equals to integral 0 to pi by 4 tan x to the power of 5 dx. Here n for 5, 1 by 5 minus 1 minus 1 by 5 minus 3, enough. And actually minus after you get plus sign, but it is odd. Odd means you will be getting I1 right on. Here see, where I1 is equal to half log 2, remember. Where I naught is equal to x. This is even, power is even. Odd, so we need to write I1. I1 means half log 2. This equal to, we have 1 by 4 minus 1 by 2 plus half log 2. So that means half log 2, 1 by 4 minus half is minus 1 by 4. So second option is the right option. Second option is the right option. Okay. 1 by 4. 1 by 4 minus half means 4 LCM. You will be getting 1 minus 2 minus 1 by 4. Understood now? Right. Forty-eight question. Integral 0 to pi by 4 tan x to the power of 4 plus tan square x dx equals to, first option 1, second option 1 by 2, third option 1 by 3, fourth option is 1 upon 4, 1 by 4. Okay. Now the solution. Let us say this I equals to integral 0 to pi by 4. Here take tan square x common. If you take tan square x common, you have 1 plus tan square x dx. The 1 plus tan square x is nothing but secant square x. So this equals to integral 0 to pi by 4 tan square x into secant square x dx. Now the tan x derivative is secant square x. Now we have the formula here. Integral f of x to the power of n into f dash x dx equal to f of x to the power of n plus 1 by n plus 1 plus c. So this equals to, we can write tan x derivative is secant square x. This we can write tan cube x upon 3. Limits 0 to pi by 4. So this equal to tan pi by 4 is 1. 1 cube is 1. 1 by 3 minus tan 0 cube. 0 by something 0. So answer is 1 by 3. So now we have the shortcut. So what is the shortcut we have? See the shortcut. Shortcut is integral 0 to pi by 4 tan x to the power of n plus tan x to the power of n minus 2 dx is equal to 1 by n minus 1. This is the shortcut. 1 by n minus 1. Here see, n equals to how much? N equals to 4. Therefore I equals to, we can write 1 by n minus 1. 1 by 4 minus 1 is 1 by 3. So directly one step we can write the answer. That's why option 3 is the right option. Option 3 is the right option. I explained the method as well as. So for this problem actually we need not draw the diagram. If you draw the diagram, it becomes very lengthy. Whenever if necessary we need to draw the diagram. That is the one of the strategy. Understood now? One of the strategy we need to apply. Just now I discussed about the graph only, Nani. For mod x function, for step x function, that is necessary. Okay. Yesterday I watched my episode. In that I had drawn. Yes, even for cot also you can apply. Forty-nine. 0 to pi by 4, 0 to pi by 4, secant x whole to the power of 6 dx equals to first option. First option is 8 upon 15. Second option is 35 upon 8. Third option is 44 upon 15. Fourth option is 28 upon 15. So the reduction formula for secant x we need to. Okay, thank you, Divya. Right. So now let me write the formula for integral 0 to pi by 4. This is in secant x to the power of n dx equals to root 2 raised to n minus 2 n minus 1 plus n minus 2 upon n minus 1 in minus 2. Here I0 or I1 is the accordingly n is even or n is odd. Okay, that we need to remember. Well, let us do it now. So this formula need to be applied for this one. We need to recall this one. Right, let us do it. So definitely second year algebra also I will explain later. Matrices completed. Now the solution. So I6 we need to find out. I6 equals to root 2 power 6 minus 2 4 upon 6 minus 1 plus 6 minus 2 6 minus 1 I how much we will be having I4. This will be root 2 power 4 means root 2 power 4 means 2 square 4 upon 5 plus 4 upon 5 I4. Say equation 1. Let us find out I4 now. I4 equals to root 2 4 minus 2 2 directly I will write now 4 minus 1 3 plus 4 minus 2 2 upon 3. This will be I2. So what is I2? I will explain. I2 is equal to integral secant square x dx. Am I correct now? 0 to pi by 4. That is tan x. Limits we have 0 to pi by 4. Tan pi by 4 is 1. 1 minus 0 1. So I2 means you can write 1 here. This is equal to root 2 square 2. 2 by 3. 2 by 3 plus 2 by 3. This will be 4 by 3. Now from equation 1 let us find out. From equation 1. Okay. From 1. So from 1. I6 equals to 4 by 5 plus I4 is actually 4 by 3. 16 4 by 5 into 4 by 3. Here 15 is the LCM. 12 plus 16, that is 28 upon 15. So that means fourth option is the right option. Fourth option is the right option. Enough, Mamata. Okay. Right. Next now, question number 50. Integral 0 to pi by 2. Integral 0 to pi by 2. Sin x to the power of 8 cos square x dx equals to, first option pi by 512, second option 3 pi by 512, third option 5 pi by 512, fourth option 7 pi by 512. So this is the question. Right. So we have the shortcut. Let me reduction formula. See, IN equals to integral 0 to pi by 2 sin x to the power of m cos x to the power of n dx equals to m minus 1 and subtract 2, m minus 3 subtract 2, m minus 5 and so on dash dash. This is not bracket function, only simple bracket, multiplied by n minus 1 subtract 2, n minus 3 n minus 5 dash dash upon, add these two powers, m plus n into m plus n minus 2, m plus n minus 4, m plus n minus 6 and dash dash into k. Here k equals to pi by 2 if both m and n are even, otherwise k equals to 1. That's all. K equals to 1. So now we need to solve now formula. Here directly we can apply here. So this required formula, what we need to find out, I8 comma 2 we need to find out. So that means 8 minus 1 7 into 7 minus 2 5 into 5 minus 2 3 into 3 minus 2 1. Completed. After that you will be getting negative value. Stop. Next let us go for n minus 1. N is how much? 2. So 2 minus 1 1. Stop. Upon m plus n. M plus n means 8 plus 2 10 into 10 minus 2 8. 8 minus 2 is 6. 6 minus 2 4. 4 minus 2 2. Stop. Into k value is actually both are even. M and n are both are even. That means pi by 2. So you simplify this one, you will get the answer. So if you simplify, what do you get now here? See, this one 3 2 ja, 5 1 ja, 5 2 ja. That means you will be getting 7 pi upon 2 into 2 4, 4 into 4 16, 32, 32 into 16, 16 2 ja 32, 48 on 5 12, so 512. That means fourth option is the right option. Fourth option is the right option. 7 pi by 512. Right. #51. Question number 51. Okay. Question number 51. Integral 0 to pi by 2. 0 to pi by 2. Sin x to the power of 8. Sorry. Sin x to the power of 6. Cos x to the power of 5 dx. Sin x raised to 6 and cos x to the power of 5 dx. First option 8 by 693. Second option 5 by 693. Third option 4 by 693. Fourth option 10 by 693. Okay. Now the solution. This is I 6 comma 5 you need to find out. First 6 minus 1. Sorry, wait. Directly we can write. So 6 minus 1 is 5 into 5 minus 2 is 3. 3 minus 2 is 1. Stop. Next start with 5. 5 minus 1 4. 4 minus 2 2. That's only. 2 minus 2 0. You don't write it. Upon 6 plus 5 11. 11 into 11 minus 2 9. 9 minus 2 7. 7 minus 2 5. 5 minus 2 3. 3 minus 2 is 1. Stop. Here actually both are this is even, this is odd. That's why here k value is 1, not pi by 2. Now into 1. So now any cancellation? Yes, 3 gets cancelled. 5 gets cancelled. Nothing. So 4 2 ja, you will be getting 8. So that means 63 into 11. 63 into 11 means 6 plus 3 and 3. That will be 693. So 693. 8 upon 693. First option is the right option. First option is the right option. Okay. #52. Question number 52. Question number 52. Limit extends to 0. Integral 0 to x sin square t cos t dt upon x cube equals to first option 1, second option 1 by 2, third option 1 by 3, fourth option 2 by 3. So this is the problem. 52nd question. So if you apply the limit, what will happen? Let us see. So if you apply the limit, it becomes like this: 0 to 0 upon 0 cube 0. So a to a, any integral is 0. 0 by 0 is indeterminate form. Whenever it is indeterminate form, okay, whenever it is indeterminate form, apply L'Hospital's rule. So solution now, apply LH rule. That means differentiate numerator separately, denominator separately. So if you want to differentiate numerator, we need to use Leibniz rule. So what is the Leibniz rule means? We can write like this: limit x approaches to 0. Leibniz rule means in the place of t, upper limit write down sin square x cos x, x differentiation 1, and minus lower limit sin 0 0 0 into something 0, you need not write it, upon x cube differentiation is 3x square. Now just we need to apply the limit. This function becomes limit problem. This we can write like this: 1 by 3 common, limit x approaches to 0. This we can write sin x by x whole square. Am I correct now? Into limit x approaches to 0 cos x. This limit x approaches to 0 sin x by x is 1. Limit x approaches to 0 cos x is 1. This equals to 1 by 3 times 1 square into 1. So answer is 1 by 3. That means option 3 is the right option. Option 3 is the right option. Right. Understood now? I applied Leibniz rule for this one. Leibniz rule, you need to remember. Fifty-third problem. 53rd problem. Sorry, 54th, I think so. 54th. Limit x approaches to 3, 1 upon x minus 3 times integral 3 to x e power x dx equals to, first option is e cube, second option is 1 by e cube, third option e square, fourth option e. This is the question. So now if you apply the limit, what happens? Let us see. This becomes like this: integral 3 to 3 e power x dx upon 3 minus 3. This will be 0, 0 by 0 form. Whenever 0 by 0 form is called indeterminate form, we can apply LH rule. So let us apply LH rule. Differentiate, this will be the numerator, this is the denominator. If you differentiate, what you get means actually here e power x, x differentiation 1 minus e cube into 3 differentiation 0. This is Leibniz rule. By x minus 3 differentiation 1, you need to apply the limit. Limit x tends to 3. So that means you get e cube minus 0 upon 1. This equal to e cube. So that means first option is the right option. First option is the right option. Yes, you think exactly correct, Dinakar. Narla Venkateshwarli, Venkata Raghuram. Okay, Venkata Raghuram. One time is enough because so that others also may type. I need to check others answers also. Right. Next 55 problem. 55. Question number 55. Integral minus 2 pi to 2 pi sin x to the power of 5 dx equals to 54. First option is 0. Second option is 3 pi by 16. Third option is 8 by 15. Fourth option is 27 by 16. Okay, right. See, integral minus 2 pi to 2 pi sin x to the power of 5 dx means here it seems to be integral a to a f of x minus a to a f of x dx. That means you need to verify evenness and oddness. That means you see you have this condition integral minus a to a f of x dx equals to 2 times integral 0 to a f of x dx. F is even. F is even. For example, 0 odd. F is odd. So this we need to check it now. Let us say here, let us say f of x equals to sin x to the power of 5. So put x for minus x to check even function or odd function. Sin of minus x whole to the power of 5. So that is minus sin x whole to the power of 5. 5 is odd. So you get minus sin x to the power of 5. So equal to minus f of x. Therefore, f of x is an odd function. Therefore, integral becomes 0. That means first option is the right option. First option is the right option. Fifty-five. Integral minus 1 to 1 log of 2 plus x upon 2 minus x dx equal to check evenness and oddness only. So let us say this f of x equals to log mod 2 plus x upon 2 minus x. So f of minus x, this is log of 2 minus x upon 2 plus x. This 2 minus x by 2 plus x can be written log of 2 plus x upon 2 minus x whole to the power of minus 1. See, using power rule, this we can write minus log of 2 plus x upon 2 minus x, which is equal to minus f of x. Therefore, f of x is an odd. So obviously the integral becomes 0. That means third option is the right option. Third option is the right option. Fifty-sixth, right. Integral minus 1 to 1 x to the power of 17 times cos x plus e power x dx. So first option 0, second option 1, third option e plus 1 by e, fourth option is e minus 1 by e. E minus 1 by e. Okay, Maulana, first subscribe. Right. Here actually x to the power of 17 times cos x plus e power x is there. So yes, exactly correct, Ashwaradi. We need to check its evenness and oddness function itself only. But let us see whether we'll get 0 or other option we need to check. See, cos x is an even function multiplied by odd function. You get odd function only. This is obviously this integral will be 0. This integral we need to find out because e power x is neither odd nor even. So let us check it now. For example, let us say this is f of x now. See, f of x equals to x to the power of 17 and cos x. So f of minus x is equal to minus x to the power of 17 cos of minus x. Cos of minus x is plus cos x. X to the power of 17 cos x. So f of x. Here f of x is e odd function. So that's why now this integral becomes like this. I equals to integral minus 1 to 1 0 plus e power x dx, because e power x we cannot check whether it is even or odd. Go back and come. Go back and come. So this we can write now integral of e power x minus 1 to 1 dx. So integral of e power x is e power x limits minus 1 to 1. That's why e minus of e power minus 1. That is e minus 1 by e. That means fourth option is the right option. Fourth option is the right option. Okay, once again I will check here also network problem. Wait now. I will refresh here also. So okay, it's no problem. Okay, I will refresh once again. Wait all of you, 1 minute. Okay, now everybody getting? Fifty-seven. Integral 0 to pi cos x to the power of 5 dx equals to. Okay, Dishwank. First option 1, second option 0, third option 1 by 7, and fourth option pi. Okay. So thank you. Now, so first 0 to pi cos x to the power of 5 dx means if you want to write a reduction formula, that should be upper limit should be pi by 2. That's why we need to check f of a minus x. If f of a minus x is equal to minus plus f of x, then 2 times 0 to pi by 2 we can write it. If f of a minus x is equal to minus f of x, then obviously we need not do anything, simply we put answer 0. So that we need to check it now. See, let us say this is f of x. So this will be a. Now f of x equals to cos x to the power of 5, f of a minus x, pi minus x, cos pi minus x, cos 180 minus theta minus cos theta. This is minus cos x to the power of 5. 5 is an odd number. Minus raised to odd, minus you get minus cos x to the power of 5. Again, this will be minus f of x. So f of a minus x is equal to minus f of x. That's why we have this formula. What is the formula? Integral 0 to a f of x dx equals to 0 if f of a minus x equals to minus f of x. This is the result we studied. That's why this I becomes 0. Integral becomes. Second option is the right option. Second option is the right option. Right, Suma. 58. Integral 0 to 2 pi. Integral 0 to 2 pi sin x to the power of 7 dx equals to first option 0, second option 1, third option 2, fourth option 3. So this question also same. So let us say this is f of x. This will be a. F of a minus x we need to find out. So let f of x equals to sin x to the power of 7, f of a minus x 2 pi minus x sin 2 pi minus x raised to 7, sin 360 minus theta minus sin theta. minus sin x raised to 7. This equals to minus sin x to the power of 7. This is minus f of x. So we have the formula. What is the formula? Integral 0 to a f of x dx becomes 0 provided if f of a minus x equals to 0. Sorry, minus minus f of x. So therefore this integral I, this I becomes 0. So first option is the right option. First option is the right option. Right option 1. Narla Venkateshwarlu. Yes, Narla Venkateshwarlu, you are there. Fifty-nine. Okay, 59th question. Right, 59th. Akshay. Odd function. So you are not actually hidden by anybody, I think so. Some others. Integral 0 to pi sin x to the power of 7 dx equals to, first option 2 pi upon 35, second option 32 upon 35, third option 34 upon 35, fourth option 17 upon 35. Okay. Now we are getting point. What happens? Okay. Here now integral 0 to pi sin x to the power of 7 dx. If it is integral 0 to pi by 2, directly we can apply the reduction formula of 0 to pi by 2 sin x to the power of n. But we need to check here. F of a minus x we need to check. If f of a minus x equal to f of x, then our answer will be 2 times integral 0 to, yes, right. So now see integral, let us say this is f of x now. See, f of x equals to sin x to the power of 7. This will be upper limit a, f of a minus x, f of pi minus x. So sin pi minus x whole to the power of 7. Sin 180 minus theta. 180 minus theta lies in the second quadrant. Second quadrant is actually positive. Sin is positive. Sin 180 minus x, sin x. So sin x to the power of 7. F of x, you get it. So we have the formula now. Integral 0 to a f of x dx equals to 2 times integral 0 to a by 2 f of x dx if provided f of a minus x equals to f of x. This result need to be applied for this one. So now we get like this. Okay. Now integral I becomes here 2 times integral 0 to pi by 2. Very careful, observe, a by 2 means pi by 2 sin x to the power of 7 dx. Now 7 is the odd number. All of you listen very carefully. Important shortcut I will explain. Very, very important shortcut. Already 2 is there. Keep in the outside, no problem. But only we are discussing about integral 0 to pi by 2 sin x to the power of 7 dx. How to find out? Whenever odd power is there, count from 2. Count from 2. Even is there, count from 1. So I am counting. See, 2, 3, 4, 5, 6, 7. Stop. Because we need to count from 2 to 7 only. And multiplied by, whenever odd power is there, multiply with 1. Even power means you need to multiply with pi by 2. See now what happens now here. 3 1 ja, 3 2 ja. Over now. This equals to 4 2 ja 8, 16, 32 upon 7 5 ja 35. So second option is the right option. I think this shortcut actually nowhere you cannot find out this kind of shortcut. So that's why you need to concentrate on this one. Solve as many as problems without any formula. We can do it. I will repeat. So whenever here odd power is there, start the counting from 2. How to count? 2 up, 3 down, 4, 5, 6, 7. Stop. Into 1 rather. For example, if it is the power is even, start the counting from 1. Okay, all of you understood now? Have you enjoyed this shortcut? Have you enjoyed or not? Right. Sixty. Integral 0 to pi by 8 cos 4x to the power of 6 dx. Okay. Right. First option is 5 pi upon 128. Second option 35 pi upon 128. Third option 25 pi upon 128. Fourth option 5 upon 128. Okay. Yes, it's very easy to remember. Now integral 0 to pi by 2 some cos x to the power of something is there, we can apply the shortcut. So that means now we need to change the limit, upper limit, as well as this need to be changed as cos x to the power. Understood now? Right. So golden jubilee. Why? Golden jubilee means 60. Okay. Right. You are so funny. Let us say t equals to 4x. Put x is equal to 0. Then t becomes 0. This is lower limit. Put x is equal to pi by 8. Now t equals to 4 times pi by 8. that is pi by 2. This becomes upper limit. Now dt equals to 4 dx, or dt by dx is equal to 4, dt is equal to 4 dx. So now this integral I becomes, this is actually I6. Integral limit has been changed to pi by 2 cos t power 6 dx equals to dt by 4 you can write. Now you can apply the shortcut. 1 by 4 common. Let us write one more step. Shortcut is very simple. So cos t to the power of 6 dt. T is dummy variable, don't worry. 6, you remember. 6 is even. Even means you need to start the counting from 1. See, you leave it this 1 by 4 multiplied by, only concentrate on this one. Counting, you need to count from 1 to 6 like this. 1, 2, 3, 4, 5, 6. Stop. As it is even power, you need to multiply with pi by 2. If it is odd, you need to multiply with 1. So now 15 pi you will be getting 3 1 ja, 3 2 ja. Right. You will be getting 5 pi by 2 2 ja 4, 4 4 ja 16, 16 2 ja 32, 32 4 ja 128. So that means first option is the right option. Not think exactly correct, Narla Venkateshwarlu. No option. 5 pi by 128. 15 pi. How it is 15 pi? Right. Option 1. Right. Now you can check it. Okay, 61. $61. Zero to pi cos x to the power of 8 dx equals to, first option 5 pi by 16, second option 35 pi upon 128, third 5 pi upon 18, fourth one 5 pi by 18. Right. Okay, I will inform to the technical team. Saranya, don't worry. Okay, let me solve this problem. Right. Not like Venkateshwarlu too. Okay. First, let us say this is f of x. Here, upper limit is not pi by 2. That's why we need to check f of a minus x. So let f of x equals to cos x to the power of 8, f of pi minus x cos pi minus x whole to the power of 8. This is minus cos x to the power of 8 plus only cos x to the power of 8, this is f of x. So we have this formula, integral 0 to a f of x dx equals to 2 times 0 to a by 2 f of x dx if f of a minus x equals to f of x. Okay, using this condition, now we can write this I8, we can write like this, 2 times integral 0 to pi by 2 cos x to the power of 8 dx. And now tell me, what shall we do? One check, sir. Right. So now how to count? We need to count from 1. Am I correct now? 2 times 1, 2, 3, 4, 5, 6, 7, 8. Stop. Even power. So multiply with pi by 2. Here 3 1 ja, 3 2 ja. This 2 gets cancelled. That means 35 pi upon 16 into 8, 128. That means second option is the right option. Yes, count from 1. When do you count from 1? N is even. When do you count from 2? When is n is odd. Ajay Khanna. Right. Sir, option 3, option 4 are same. Option 3, option 4 are same. Yes, yes. Good observation. Good observation. Now it is okay. Now it is okay. Now it is okay. Sixty second. Right. Integral 0 to pi cos cube x sin x to the power of 4 dx. First option 0, second option 1, third option 16, fourth option is 3 pi by 16. 3 pi by 16. Right. Even the sin x to the power of m, cos x to the power of n dx form is there. Upper limit must be pi by 2. So that means we need to check f of a minus x also in this case also. So let us say this is f of x function. This will be a. This will be a. So let f of x equals to cos cube x sin x to the power of 4. So f of pi minus x cos of pi minus x cube whole cube sin of pi minus x whole to the power of 4. Now cos 180 minus theta minus, so this will be minus cos cube x sin 180 minus x sin x to the power of 4 sin x to the power of 4. This will be minus f of x. So we have this shortcut. What is the shortcut? Formula integral 0 to a f of x dx equals to 0 if f of a minus x equals to minus f of x. Therefore, I equals to 0. First option is 1. Sixty-three. Integral 0 to 2 pi cos x to the power of 7 sin x to the power of 5 dx. Okay. First option 1, second option 0, third option is 5 pi upon 16, fourth one is 3 pi by 8. Okay. So first we need to check the f of 2 pi minus x is equal to f of x or not. Right. So this one, f of x equals to cos x to the power of 7 sin x to the power of 5. F of a minus x, this is a. F of 2 pi minus x equals to cos 2 pi minus x whole to the power of 7 sin 2 pi minus x whole to the power of 5. Cos 360 minus x is equal to cos x. This is cos x to the power of 7 multiplied by sin 360 minus x sin x minus sin x to the power of 5. This equal to minus cos x to the power of 7 into sin x to the power of 5, which equal to minus f of x. Therefore, directly I have already repeated several times formula, so 0. Second option is the right option. Sriya, when do you have the examination? When do you have the examination? Right. Now the 64th question. 64th. Okay, 6th July. Still 6th July it will complete, don't worry. Integral root 2 to x dt upon t root of t square minus 1 equals to pi by 2. Then x equals to, that means solution of this equation. First option 2 root 2, second option 2, third option pi, fourth option minus root 2. Okay. So one more thing to the viewers, actually on June 2nd I have my personal work is there, I have other work. So in June 2nd you may not have the classes, either morning classes and evening classes, that will be postponed. So that will compensate today and tomorrow. The two classes will be dealt today and tomorrow. And June 2nd you don't have any class. So let us solve this problem now. Solution. This is integral of 1 by t root of t square minus 1 dt is secant inverse t. Secant inverse t limits root 2 to x equals to pi by 2. We need to solve this equation now. Secant inverse x minus secant inverse root 2 upper limit minus lower limit equal to pi by 2. Secant inverse root 2 is 45 degrees. Secant inverse x minus pi by 4 equal to pi by 2. This secant inverse x equal to pi by 2 plus pi by 4. Now this is the inverse trigonometric function concept. X equals to sec of 90 plus pi by 4. Sec 90 plus theta is minus cosec theta minus cosecant pi by 4. Cosecant pi by 4 is also root 2. So minus root 2. That means fourth option is the right option. Question number 65. Question number 65. Integral 0 to infinity 45a upon 3 plus a plus at power 4 dt equal to. So in June actually tentatively one or only two classes I will take in a week. First option 15 upon 3 plus a whole square. Second option 15 upon 3 plus a whole cube. Third option 15 upon a times 3 plus a whole cube. Fourth one 15 upon a times 3 plus a whole square. This is the problem. Okay, here 45a 3 plus a plus t. Okay, better you do like this now. Suppose let us say this 3 plus a plus at equal to something, say x. So we need to change the limits also. First differentiate it. Dx by dt equals to 0 plus a. This is a. So dt equals to dx by a. So this we need to write upper limit. Here x approaches to infinity. X approaches to infinity. X also, here t also approaches to infinity itself only. Lower limit x0, that implies x0 means here x0. Okay, so we can do directly, we can do, it becomes very lengthy. I will explain easy method rather than this becoming very lengthy. Leave it now. I equals to integral 0 to infinity. This 45a take out common. This we can write 3 plus a plus at whole power 4 minus 4 dt. This is x to the power of minus 4. What is the x to the power of minus 4? X to the power of n plus 1 by n plus 1. So you can write 45a times 3 plus a plus at whole to the power of minus 4 plus 1 minus 3 minus 3, but at differentiation is a divided by a. Here limit 0 to infinity you need to apply. Here a gets cancelled. So this will be, you can write now 3 1 ja 3 15 ja, but minus 15 times you can write, this will be 1 by 3 plus a plus at whole cube, limits 0 to infinity. Limit extends to infinity, this becomes infinity, 1 by infinity is 0, so minus 15 times 0 minus 1 by, in the place of t substitute 0, this becomes 0, 3 plus a whole cube. So this will be minus 15 into minus 1, 15 upon 3 plus a whole cube. So that means second option is the right option. Second option is the right option. One minute, you will be getting, wait. $66. Priya, this will be useful for Andhra Pradesh and Telangana, all over from Kashmir to Kanyakumari, it will be useful. Zero to infinity, a power minus x, b power minus x, dx, where a greater than 1, comma b greater than 1 equals to, first option log ab, second option 1 upon log ab, third option 1 upon log a plus 1 upon log b, 1 upon log a minus 1 upon log b. This is the question. Right. Now the solution. First we need to do this problem. Integral 0 to infinity a power minus x dx minus integral 0 to infinity, we need to split it as a difference of two integrals, b power minus x dx. A power minus x is a power minus x upon log a, but minus x differentiation is minus 1, minus log a, put minus, limits 0 to infinity, minus this also minus of, you will be getting b power minus x by log b minus limits 0 to infinity. So you get like this now, a to the power of minus x, as x approaches to infinity, a to the power of minus x when a greater than 0 is become 0. So that means minus common, you get 0 by something 0, minus a power 0 1 by log a. In the similar fashion, minus into minus plus, as x approaches to infinity, b power minus x is 0, 0, minus b power 0 is 1, 1 by log b. This minus into minus plus, 1 upon log a or 1 by log a, minus 1 upon log b or 1 by log b. This answer. Okay. Next question. '67. Integral 0 to a root over a plus x upon a minus x dx. First option, a by 2 times pi minus 2. Second option, a by 2 times pi plus 2. Third option, a by 3 times pi plus 3. Fourth one, a by 3 times pi minus 2. This is the question. Right. Integral 0 to a root of a plus x by a minus x dx means we need to rationalize the denominator with the root of a plus x. Multiply both numerator and denominator with root of a plus x. Then after that we need to integrate or substitute the upper limit and lower limit. So don't put x is equal to a cos theta. It becomes very lengthy. So now the solution, I becomes integral 0 to a root of a plus x upon root of a minus x multiplied with root of a plus x upon root of a minus x dx. So this equals to integral 0 to a plus x upon root of a minus x into a plus x is a square minus x square dx. Separate the integrals now. A common, integral 0 to a 1 by root of a square minus x square dx and plus a square minus x square differentiation is actually minus 2x. So we can write directly this one like this without making its identity. Minus 1 by 2 write down integral 0 to a minus 2x upon root of a square minus x square dx. Can we write like this? You check it. Any difference? 2 gets cancelled, minus into minus plus only. Now see, this is the derivative of this one, f dash x by root f of x. This becomes 2 root of f of x. This is the actually standard formula. So we can write a times sine inverse x by a limits 0 to a and minus 1 by 2 into 2 times root of a square minus x square minus root of a square minus x square limits 0 to a. So a times sine inverse a by a, sine inverse 1 is pi by 2, sine inverse 0 0 minus of, first substitute x for a square minus a square 0 minus root of a square is a. This will be a pi by 2 plus a common, or a by 2 common, you get pi plus 2. So second option is the right option. Second option is the right option. Second option is the right option. So everybody get it now? Okay, but you need to change the limits. Narla Venkateshwar, am I correct now? Right. Okay, no problem. Any method you can do it. Any method, useful method you can adopt. I don't restrict and also I don't recommend also. Integral 0 to log 5 e power x times root of e power x minus 1 upon e power x plus 3 dx. Yes, you need to change the limits, I told. First option pi plus 2, second option pi minus 2, third option 4 minus pi, fourth option 4 plus pi. This is the question. So what is Mr. Rishi Kumar? What do you want? Where are you from? Let us say this is equal to t first. What will happen? Let us see now. Solution. Let us say t is equal to e power x plus 3. Now dt by dx equal to e power x and dx. Limits we need to change. Okay. Lower upper limit we have x for log 5. That is t equals to e to the power of log 5 plus 3. Very interesting this is. E to the power of log of something is something. 5 plus 3 is 8. Now upper limit has been changed to 8. Now lower limit x is 0. Now t equals to e power 0 plus 3. 1 plus 3, that is 4. Now this integral becomes like this. I equals to integral, limits has been changed. Lower limit 4, upper limit 8. Correct? So this root of e power x equals to how much? T minus 3. This becomes t minus 4 into here e power x into dx. What is e power x into dx? That will be dt. Upon this will be how much you have? E power x plus 3 is equal to t. Then we need to do this one. How to do? Okay, we need to check it now. We need to check it. Okay. Okay, no problem. Here also we can do. One more substitution will get it. T minus 4 is equal to u square, you say. This dt is equal to 2u du. Now this becomes very lengthy. Okay. Integral 4 to 8 write on u upon this will be u square plus 4 dt is 2u du. Okay. Limit changes. See here what we need to take here. T means 4, t means 8 you need to take. That means this becomes 0. 4 minus 4 0. Upper limit is 8. U square is equal to 4. This will be 2. Okay, this we need to do it now. Integral 0 to 2 u by u square plus 4. U by u square plus 4 into u du. Okay, 2 common. 0 to 2. This is u square. Add 4 and subtract 4. U square plus 4 du. This is 2 times. Now separate the integral. 0 to 2 u square plus 4 by u square plus 4 1 du. This is minus integral 0 to 2 4 upon 1 by this you can write u square plus 2 square du. So now this equals to 2 times u limits 0 to 2 minus 4 times this will be tan inverse u by 2 into 1 by a. 1 by a means 2. Limits 0 to 2. This will be 2. So 2 times 2 minus 0 minus 2 times tan inverse 1 pi by 4 minus 0. This will be 2 times 2 minus pi by 2. So what is the answer is there? You need to check it now. Right now. 2 into 2 4 minus pi. 4 minus pi. Third option. So better instead of doing like this, better directly you can say e power x minus 1 is equal to t square. You will get directly. No shortcut for this problem we have, but I did very lengthy method. Better you say e power x minus 1 is equal to t square. Directly you get it. This lengthy method shall be avoided. So once again you complete it with the help of e power x minus 1 is equal to t square. 69th problem. 69th problem. Yes, Venkateshwar, that's correct. What you said is correct. Integral 0 to infinity dx upon x plus root of x square plus 1 whole to the power of 3 equals to first option 3 by 8, second option 3 by 4, third option is 3 by 2, fourth option is 8 by 5. This is the problem. Definitely Manoj Ban I will do, especially on functions I will do. So July after onwards actually I do the videos on total concept and as well as the problems. Till then it is going on EAMCET, so that some sort of concepts as well as the problems I have been discussing. Right. See, generally if you put x is equal tan theta, you will get this question, but this will be very lengthy. We have one shortcut. Let me explain the shortcut. What is the shortcut formula? Shortcut formula is equal to integral 0 to infinity dx upon x plus root of x square minus 1 whole to the power of n equal to n upon n square minus 1. N belongs to set of natural numbers. Right. So that means actually here n equals to 3. Therefore I equals to 3 upon 3 square minus 1, 3 upon 9 minus 1, 3 upon 8. That means first option is the right option. Okay. Okay, thank you one and all. We shall continue in the next session, because today evening also you have 1 hour class, and by 9 o'clock also, evening 9 o'clock also you have 1 hour class. Today let it be make, because I have already told you, sir, your lecturers are enough for EAMCET 2020 reply. Siddhartha, I think you joined today. For new viewer, how can I judge you? See, just you watched only one video. Watching one video, can you give the feedback? You ask the regular viewers. Siddhartha, it's not good, it's not fair. The question is vague. Right. See, let me say on June 2nd you have the holiday. Right. So today 2 sessions you shall have. The evening session, it may be in between 4:30 and night 9 to or 8 to 8:32. So because today I will start binomial theorem concepts also, very very important, because after that binomial theorem, besides next even functions, followed by the functions, I take up the classes. So today, tomorrow there will be three sessions, and June 2nd you have the holiday for both the sessions. So thank you one and all. I will meet you in the evening session. Thank you one and all. Bye bye.